complex numbers u and v are defined by minus 4 plus 2i, 3 plus I, u over v. So u over v is minus 4 plus 2i over 3 plus I. We have to multiply both parts by the complex conjugate of the denominator. So look at the denominator. We have 3 plus I, the conjugate is 3 minus I. Okay, so we realizing the denominator, just like rationalizing denominator. So after we multiply minus 4 times 3, we get this, minus 4 times minus I plus 4i, 2 plus I, 6i, 2i minus I times minus I, we get minus 2i squared, and in the denominator 3 times 3 is 9, 3 times minus I minus 3i, I times 3 plus 3i, I times minus I squared. I squared is minus 1, so that's why this is actually plus 2. I squared is again minus 1, so this is actually plus 1. So in the end we have, this is actually minus 10, and this is actually 10, so minus 10 over 10 is minus 1, and 10i divided by 10 is just I. So that's the final answer in the simplest form. Okay, that's u over v. Now in exponential form. So previously we know that in Cartesian form this is u over v. So just draw the Argand diagram. Minus 1i, so this is the complex number. We need the r, or the hypotenuse, or the modulus, and we need the theta from the positive real axis or the positive x-axis. So just draw this kind of triangle here. If you look at this triangle, we have the length 1 and also 1. So the hypotenuse is root 2 using Pythagoras, and the angle is actually isosceles, so 45 degrees, but we have to use radians, so pi over 4. Okay, but remember we are looking for the angle from positive x-axis or positive real axis, so 180 degrees minus, or pi minus pi over 4, we get 3 pi over 4. So this is the r, this is the theta. Alright, next. State fully the geometrical relationship between OA and BC. So ABC represent UV. Okay, so the U is A, minus 4 plus 2i. This is the U, this is the V. From the previous part, we know the U and the V. And the 2U plus V would be 2 times minus 4 plus 3, that's minus 5. 2 times 2 plus 1, that will be 5. Okay, so 2u plus v, and the point A is u, so A is minus 4 plus 2. This is the coordinates of A, this is the OA, and for V, that is 2 plus 1, so this B. Actually, B is 3 plus 1, so 3, 1, so this is B. And C is minus 5, 5, so minus 5, 5, this is C. Okay, so we have OA and we have BC. And state fully the geometrical relationship. If we look at the gradient, this is 2 and 4, rise over run. And this is 4 and 8, rise over run, which means they are parallel. And if you look at the length here, BC and 2A, because we multiply by 2, so of course the length should be also a multiple of 2, so the length BC is twice the length OA. Alright, that's it. Okay, part D. Prove that the angle AOB is 3 over 4 pi. So previously we know the A, and we know the B. To find the angle AOB, well, we can just do pi radians minus alpha minus beta, and to find alpha and beta we can use inverse tangent. So tangent alpha would be, this is the right angle triangle, opposite over adjacent, so inverse tangent 2 over 4, and for the beta, inverse tangent 1 over 3, and then use a calculator. You should get what we need to prove. Alright, I'll see you again next time.